So what we're working on today is section 7.5, which now we're leaving parallelograms and we're going to the world of trapezoids and kites. Okay? So the first step you got to be able to do, the first target is to be able to know when it is a trapezoid or kite. The second one is understanding the rules of trapezoids and kites. There's not many, but there are some rules. And then the last one is to be able to find measures and missing angles and solve equations based on those rules. Okay? And so you'll have 4 different assignments that you need to complete after this. So a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. If it was 2 sides parallel, then it would be a parallelogram. So the parallel sides are called your bases. Those are the bases. The non-parallel sides, these are your legs. Okay? Now, when you have legs, if you circle the angles, those angles in there equal 180. And these angles over here are also going to equal 180. D and C don't ever do anything, but A and D make 180 and B and C make 180. Okay? So it's different than parallelograms. Parallelograms, any angles next to each other made 180s. But for this one, it's only the ones with the legs. Okay? All right, so when you deal with trapezoids, there is a specific type of trapezoid. There's one type, and it's called isosceles trapezoid. And with an isosceles trapezoid, it's similar to the idea of an isosceles triangle. And in an isosceles triangle, you have 2 equal sides. So with an isosceles trapezoid, you have 2 congruent legs. Bases aren't congruent, it's the legs. So the left leg is equal to the right leg. Now, when you have that, then that tells you your base angles are congruent. So that would tell me if this one was 80, this base angle over here was 80. And then one more rule about diagonals, and the diagonals of isosceles trapezoids are congruent. Okay, so what we need to do now is this first example is to find the missing angles. And so my suggestion is always just to mark the legs. So this is a leg, this is a leg. And if I look at this first section up here, I circled the legs. The angles that are circled, those are the ones that add up to 180. So here, these add up to 180. So 180 minus 73, 107. 180 minus 125, 55. Okay, and I guess I haven't done the Dora pause, so I'll zoom out and pause. And while you're pausing, I'd like you to see if you could do part B. Yeah, so see if you could do B. Okay, all right, so if you've tried B, great. If not, I know that these are my legs. And with isosceles, legs are equal. Base angles are equal. So this one's 78, this one's 78. Well, if I still circle my leg, they still add up to 180. So 180 minus 78 is 102. But this is also 102 because I circle that leg and they add up to 180. Okay, so trapezoids have some different rules. Make sure you have them all caught up. Do a little Dora pausing to make sure you have them and you're ready to go on. Okay, so we're not done with trapezoids. Now what we're going to do is we're going to need to see if they are isosceles. So what I would like you to do is I'd like you to start off by graphing the points on both of them and then hit pause or unpause it so that we could talk about it. Okay, so for the first one we have a trapezoid, and I know it's a trapezoid because this is up 2 over 1, and this one is up 4 over 2, which reduces to 2 over 1, so opposite sides are parallel. Now, the best way to figure out if this is isosceles, if it's isosceles, then the legs, the non-parallel sides have to equal. And the easiest way to find out if they're equal is see if they have the same slope without reducing. This one has a slope of down 2 over 2. Okay? So that's actually, if I applied Pythagorean theorem, it would get 4 plus 4, which is the square root of 8. But again, you can just look at the slope. This one, all I did was I went over 0 and up 3. Now, they're going to be different numbers, but they have to kind of square. Okay, so what we have to do is we have to see that these are the same. And the way we do that is we're going to apply Pythagorean theorem. The difference between my x's is I went 2. So it's 2 squared. Plus the difference between my y's, I went down, which is 2 squared. 2 squared plus 2 squared is 4 plus 4, which is square root of 8. And again, this is the distance formula. Here, for this one, the difference left and right is 3, so 3 squared. But there is no difference up and down, so that's 0. So it's the square root of 9 plus 0, which is the square root of 9. These are different numbers, so it is not isosceles. If I had the same square root, then it would be isosceles. Oops. Okay? So let's look at the one on the right. It looks like these are my parallel sides, top and the bottom. So we need to do the same idea where it's the difference in x's squared plus the difference in y's squared. Okay? So to get from this one, write it down here, I went over 2 and I went up 1, 2, 3, 4. So 2 squared plus 4 squared is 4 plus 16, which is the square root of 20. If this is the same, then I get the square root of 20 again. All right, well, let's look at this. The difference left and right is 1. 1 squared. The difference up and down is 1, 2, 3, 4, 5. 5 squared. Well, 1 squared is 1 plus 25 is the square root of 26. Again, these numbers are different, so it's not isosceles. Okay? All right, so let me zoom out, and I'm going to let you make sure that you can pause this. Here's the door pause. So go ahead and make sure you have that copied down. All right. The next one we're going to do is the next topic is called a mid-segment. And a mid-segment is kind of what it sounds like. It's in the middle. And so a mid-segment is made by connecting the midpoints of the legs. So I have the midpoint of AD, and I know it's the midpoint because they're equal. And then I have the midpoint of BC. And if I connect them, that right there is called the mid-segment. Okay. Now there is a rule of the mid-segment, and the length of the mid-segment is half the sum of the bases. So the mid-segment equals 1/2 of base 1 plus base 2. That's kind of in a formula that will work. Okay, so let's look at this problem. 18 is the mid-segment, so 18 equals half the sum of the bases. The two bases are x and 22. So to solve this equation, I'm just going to get rid of this fraction. I'm going to multiply by 2, and I get 36 is equal to x plus 22. And then now I subtract 22, and I get 14. So what happens is I can check this because 14 plus 22 is 36, and half of 36 is 18. So what I'd like you to do is I'd always like you to circle your mid-segment, So circle your mid-segment and see if you can set up the equation. Remember, use this. Mid-segment equals half base 1 plus base 2. And it doesn't matter which one you call base 1 and which one you call base 2. Okay? The order of them does not matter. So here's our pausing Dora for you to circle and try that problem. Okay, so our mid-segment is here. So our mid-segment equals half the sum of the two bases. Well, to get rid of this half, I multiply by 2. Now, this is something you have to be careful. You have to multiply everything on this side by 2. So I actually get 4x plus 10 is equal to 2x plus 44. I go ahead and I subtract my 2x on both sides, and so I get 2x plus 10 is equal to 44. To 34, and then I divide by 2, and I get 17. Okay, so I'm going to pause one more time to make sure that you got it written down. Okay, last section for this. This is a lot of notes today, I know. No, but we're still at mid-segment, actually, so forgot about this last problem. So go ahead and graph your points, and then we will talk about how we find the mid-segment and how we find the length and what's the best method to do. Okay, so the mid-segment connects the midpoints of my legs by Dora. Okay, so here's a leg, and here's a leg. Okay. Now, if I notice, you can kind of find the mid-segment for this one. This is this point, and then this one is right here, yeah? Now, if these were straight lines, I would find the measure of those and then divide by 2, but these are slanted lines. So what I'm going to do is I'm going to have to use my distance formula for this. And remember, your distance formula is just the difference in x's squared plus the difference in y squared. So to get from this purple point to this purple point, I would go over 1, 2, 3. So that's 3 squared. The height from this purple point to this purple point is 1, 2, 3, 4. 4 squared. So I get 9 plus 16. Don't forget our square root. And so it's the square root of 25, which is 5. So that's our the length of our mid segment. Okay, finally, let's finish this up because this is going forever. All right, so kites. A kite is a quadrilateral with 2 pairs of consecutive sides that are equal or congruent. So this one, MK, is equal to NK, and OM is equal to NO. Okay? So for kites, diagonals are perpendicular. So that means when I draw my diagonals, there's a right angle here. Now, one thing you do need to know is that one pair of opposite angles are equal. Just one. It's this one and this one. Those are my equal angles. So angle M is congruent to angle N. And so it's the angles that touch the non-equal sides. So what I'd like you to do is look at letter A and see if you can find those angles. So I'm going to start off by marking this. And I'm hoping you recognize that this is the top one and this is the other one. So this is 121. And then this is a quadrilateral. And the 4 angles in a quadrilateral equal 360. So 67 plus 121 plus 121. Let's see what that is. Gives us 309. And 360 minus 309 is 51. Okay, so let's give the Dora a pause one last time to make sure you have everything down. Okay, and so we learned about kites. Kites look a little different than what you might think. A lot of times people think a diamond is a kite, and a diamond is not a kite. For kites, the diagonals are perpendicular, so there's right angles in the middle. And if you remember, that's the same as rhombuses. Rhombuses have right angles in the middle. And then one pair of opposite sides are equal. We also learned about the mid-segment of a trapezoid. The mid-segment is half the basis. And then we learned about trapezoids, isosceles and regular trapezoids.